Welcome to the Snow and Ice Accumulation Creation module for the ForecastBuilder software. Before we dig into how ForecastBuilder creates accumulations, there are a couple of important points. First, snow and ice forecasting, like precipitation type, has several pitfalls to be concerned about. Things like QPF, the snow density, how frequently you measure are all things to think about, as they can have varying degrees of uncertainty. As such, snow on ice is a significant challenge when only creating a deterministic single-value forecast. A second important point, we strongly encourage you to utilize the Accumulation Preview button in the Analyze Adjust step. This button will give you an idea of expected accumulations based on what's included in your foundation grids, such as QPF, snow ratio, etc. If the accumulations are not matching up to expectations, revisit the foundation grids and adjust those as needed. It is strongly recommended not to modify the final accumulation grids directly, as that could throw off your internal forecast consistency and violate directives. Snow and Ice Accumulation ForecastBuilder works hour by hour, as many of our grids are hourly. However, for most offices, QPF is 6 hourly. So rather than just evenly dividing the QPF, ForecastBuilder utilizes the pop grid as a way to allocate QPF. In the example here, you can see hours 2 and 3 with the 100 pops are given the bulk of the QPF, and then that rapidly diminishes outside of those times. This hourly QPF and resultant hourly snow and ice is needed by several processes downstream, such as blowing snow and weather intensity. The QPF will be split up among all the forecast precipitation types as shown in this example. Each probability type grid will be normalized behind the scenes and used to divvy up 100% of the QPF. Pot rain's portion will be sent to a grid called rain amount. Pot snow's ratio will be used in a snow algorithm that utilizes SLR to calculate the accumulation. Pot sleet's portion will essentially use the same formula as pot snow, except it uses a static snow to liquid ratio of 2:1. Finally, pot freeze and rain's portion will be sent to the FRAM algorithm to create ice accumulation grids. You will see and hear more about this whole process in a few slides. Here's how snow amount is derived. Recall how QPF was split up earlier, and you can see that here with these equations. A couple of important notes. By NDFD definition, all snow and sleet accumulation goes into the snow amount grid. Second, should no snow ratio grid exist, a 10:1 ratio is assumed. And finally, snow amounts are reduced to simulate melt-in with another equation when wet bulb temperatures are warm. So let's jump into that. What happens in warmer environments with snow and ForecastBuilder? We'll first look at the MBM. In MBM version 4.1 and prior, once the wet bulb reached 33 Fahrenheit, snow accumulation was zeroed out. In MBM version 4.2, this was adjusted with a new algorithm built on several warm snow environments. This algorithm simply reduces the SLR or snow to liquid ratio depending on what the surface wet bulb is and how much QPF is forecast. Versus previous ForecastBuilder and MBM versions, this algorithm now can show snow accumulating in heavy QPF cases with a wet bulb temperature up to 40 degrees Fahrenheit. The MBM version 4.2 algorithm was tried in ForecastBuilder, but immediately problems were showing up, especially for light QPF events. Thus, per coordination with the developer of the algorithm for MBM version 4.2, we adjusted ForecastBuilder to the equation you see here. It results in less melt-in in that 32 to 34 range, which helps address both temperature and precipitation type uncertainty in this area, and then it follows the MBM version 4.2's curve thereafter. The reason we have to deviate here from the MBM algorithm comes from a number of factors, including that snow amount is being derived from a single forecast, whereas up to 100 inputs are deriving a NBM forecast. Ice accumulation is a little hard to show how it is created. ForecastBuilder utilizes the freeze and rain accumulation model, which has a whole set of equations that take into account things like wet bulb temperature, precipitation type, precipitation rate, and wind. An example of one of the curves is shown. Like snow amount, all the hourly accumulation is created and then summed to get the 6-hour grids. Be sure to check out the reference guide for more about the FRAM. ForecastBuilder goes above and beyond the NDFD requirements, though, to produce several other grids that can be helpful for DSS or even hazard creation. These grids include rain amount, sleet amount, ice flat accumulation, ice line accumulation. You will see these load and create in the precip type accumulation step. In certain circumstances, road temperatures can influence the amount of accumulation that occurs, especially with icing that we want to account for. A couple of scenarios are described here. You can include grids for road temperature reflecting the temperature of the roads, either above or below freezing, and it will adjust either ice accumulation or ice line accumulation based on your hourly T and road temp grids. As we look at an example here of running the snow ice accumulation step, for most situations, you are just going to press the Run Accum button at the bottom of the GUI or the Run/Continue button. This includes those used in other precipitation type derivations like snow level. If you're using the MBM method in ForecastBuilder, the accumulation functions are now built into the precip type step, as shown here. This slide applies only to the MBM methods. There is an interaction between the WX type grids with the POC grids that will be used to find the ratios of how to split up the QPF. POC grids will be automatically amended at the beginning of this accumulation step based on the WX type grids from the precip type step with the following actions. Add in values to a POC grid if a weather type was forecast that wasn't in the original POC grids, meaning a forecaster added the precip type into the forecast. Second, remove POT grid values from the calculation if a WX type doesn't exist anymore, meaning a forecaster removed that precip type. We'll say that the removal is not saved to the POC grid, but done just behind the scenes. So let's consider this example of the MBM forecast for pot rain, pot freezing rain, and pot snow. In the precip type step, the forecaster changes freezing rain to sleet. For the accumulation calculations, the POC grids will be effectively adjusted to show this new forecast. Forecasters using the MBM methods in ForecastBuilder can view the normalized grids and see how the QPF is being split up between all the forecasted precipitation types. These temporary grids are called ratio grids and will be at the bottom of the grid manager for you to view. They are only meant to provide you information and should not be edited or interacted with. Once you hit Run Continue, your accumulation grids will populate and be left with this GUI at the end. Feel free to look over your accumulation grids, but again, do not edit them. If they look unreasonable, go back, make a change upstream, say with QPF or snow ratio. Using a mixed precipitation case that impacted the KC area in early April 2020, here is a sample of the output. Given that the time of year of this case, this actually would been a perfect time to utilize the road temp grid. If you need more snow accumulation, there are 3 things that can be done as described here. If it is a mixed precipitation type event, adjust your pot grids so that pot snow has a higher value and pot rain and the other pots have lower values. This will change the ratio of QPF sent to snow accum. A helpful tip in the short term with the transition from one precip type to all snow is to utilize RAP and HER pot grids by populating them in during the Analyze Adjust step. These grids can be more deterministic than NBM forecasts are, thus directing the full QPF to pot snow and the snow accumulation equation when the changeover occurs. During light precipitation type events, one may have to increase QPF, but keep in mind that because WPC does QPF forecasting, it may not match your POP forecast and show little or no QPF where you want light snow accumulation. Finally, one can lower the wet bulb temperature by reducing hourly temperature and dew point, or RH, if you're a forecast office that does RH. It is common for snowfall to reduce the hourly temperature more than forecast. There's a nudge T to limit snow amount reduction button in the Analyze Adjust and precip type step that can be utilized if needed. Again, we strongly recommend in situations with melting to use that accumulation preview button in the Analyze Adjust step so you can see if the changes you're making to the foundation grids help. One should ensure their winter accumulations are in the ballpark before proceeding to the precip type step in case major changes need to be made to the POT grids, QPF, temperature, and or snow ratio grids. In instances where there is a strong warm nose aloft, even one with K present, the ice accumulation output from the FRAM could be too high. The FRAM does try to account for these scenarios as the precipitation type rate diagram showed earlier. However, recall the box and whisker spread in that diagram, and that's because of the CFP, you may not be able to change the QPF. In this situation, the best route to proceed is to modify the pot grids that load in this step, decrease pot freezing rain, and increase pot rain values, and then rerun the snow ice accumulation. As mentioned in the What is an NDFD Forecast module, we are working to evolve ForecastBuilder probabilistically. One way to do this is to populate NBM snow and ice accumulation directly. Those accumulations are created right out of a probabilistic spectrum versus a deterministic approach from deriving them. Of course, a challenge here is how might we modify them if needed and keep some form of internal consistency with the existing deterministic grids. That concept is still being discussed, so stay tuned. And that concludes this training. As always, please reach out via our VLab site or by our email address shown there if you have any questions. And thank you.